Okay, so we've seen speed before. We saw this in our last discussion about distance and displacement. But we've seen it with our slope. Remember, rise over run. Okay, so our rise in this case is our position with meters, and our time is our x position, our run, and that's in seconds. So if we just did rise over run, it would be meters over seconds. Okay, slope is rise over run, meters per second. Our meters are our rise, our run is our time. We have meters per second. That equals our velocity. Okay, so we could draw an equation for this line. We know that an equation of a line is y equals mx plus b. Okay. From there, we just plug in our variables that we see. Okay. We know that the slope is our velocity because it's rise over run. We know that our x is our run here, and that's our time, so we can signify that as with t. Our b is our y-intercept, which happens, y-intercept would be a position. It would be where you started. So in this case, it would be our initial position. And then y is where we end up. So that would be our final position. So when we plug those in, we've got our final position here equals velocity because that's our slope. X is on the x-axis, and that's our time. So we put time in there, plus b, which is our y-intercept, which would be where we started. Now, all I've done is change these letters. The contents of the equation have not changed. I just renamed these letters something that's on this graph. And remember, a variable is just a representation of something, so it can be anything. So these are just fine. Now, if we solve for v, we'll minus over xi, we'll divide by t, and we end up getting the velocity is equal to the final position minus the initial position divided by time. If we remember that our final position and our initial position is displacement, that's just displacement divided by time. So you're right. Physics is true. Okay, if we look at our graphs of motion, these are a little bit different. What you've got is you have a whole bunch of different letters here, and it's just a position versus time graph. We have x within meters and our time in seconds. We just need to figure out what each of these mean. So, who is traveling the fastest? We have a bunch of options here. And what do we remember about speed or velocity? It's all about slope in a position versus time because it's meters over seconds, rise over run. So in this case, the steeper the slope, the larger the number. The more shallow the slope, the lower the number. So in this case, the one with the steepest slope happens to be A. So A would be moving the fastest. If B happened to be moving downward at the same rate as A, they would both be moving the same speed. Regardless of the direction they're going, they are moving at the same speed. Okay, who's going backwards? Remember, backwards is relative to where we decide the start is. Okay, so in this case, if we decide that this is the starting point, down here at the origin, anything heading back towards the origin would be moving backwards. So B on this hand is moving from an initial position farther in front of the initial position, or of the origin, sorry, and is moving back towards that origin. He's moving backwards, back towards the beginning. Okay. C, A, and D are not moving back towards the origin, so they would not be moving backwards. Who is standing still? So if you're standing still, and I'm standing here, my position would not be changing. Okay, you sitting on the couch, or you standing in line at the movie theater, you would not be moving. And so your position is not changing. So which one of these lines represents a position that isn't changing? The answer would have to be D. Notice our position, which is on the y-axis, never changes. It's a consistent line. If we assign this to a number 1, it would be 1 all the way across. We also know this because what is the slope? It's our rise over run. Okay, our rise is 0 because we're not rising any. And so anything divided, or 0 divided by, anything divided by 0 would be, is still 0. So we have 0 slope, so we're not moving at all, so we're standing still with D. Is there anything wrong with E? A little bit. One is we've got 2 arrows. So does it start here and go this way, or does it start this way and go this way? We don't know. But also, notice at this time frame, we have a distance here and a distance here. We're in 2 places at once. We've actually gone forward in time, and at some point in time, we came back. So E has a lot of issues where we've gone forward and back in time. We're in two places at once, and that's just not possible.